An animal shelter spends $2.35 per day to care for each cat and $5.50 per day to care for each dog. Pat noticed that the shelter spent $89.50 caring for cats and dogs on Wednesday. So if you notice all of these problems, they will always have two things that they're talking about. In this case, I noticed right away that they're talking about cats and then they're talking about dogs. So first thing is to always annotate your word problem. I noticed that first they're speaking about cats. For cats, they're wasting $2.35 per day. So I circled that. And notice that I use red for cats. The next thing is that I need to define my variables. When I say define, I basically mean like I have to say one of them is going to be X and the other one's going to be Y. So for cats, I'm going to use X. And for dogs, which now I'm circling in blue, how much it is to care for each dog. That's $5.50 per dog. And the dogs will be defined as the variable Y. I also noticed that to build my equation, I'm going to have to use my total spent. So I'm going to circle that in black. So I know that they spent altogether on Wednesday $89.50. Now I'm just going to go ahead and write my equation. The first thing you'll notice is that we have to use what the information for the cats, because that's already in red. So it's $2.35. And the variable that has to be attached to it is each cat. So that will be X. So I know that for every cat, you're going to waste $2.35. Now, the next thing is that's and right here. So that means you're going to have to add that price in for how much it is to care for the dogs. And if you notice, because we already annotated, it's easy. So it's $5.50 per dog. And the dogs are represented by the variable Y. Now, the last thing is to set your equation equal to your $89.50 because that was the total spent, right? That's it. So that's your equation. So the only thing that we did is use the information in the word problem and we put it down into one equation. Next thing here says, Pat said that there might have been 8 cats and 14 dogs at the shelter on Wednesday. So because I know that for every cat you waste $2.35, I can simply go ahead and try to like solve it out. It says use your equation to justify your answer. So if I were to use my equation again, all I have to do is copy it and paste it. But instead of using the variables X and Y, now they're giving me the actual numbers. So now they're telling me that I have 8 cats and 14 dogs. So for cats, I'm going to remove the X and I'm actually going to put the cats here. It's telling me 8 cats. So it will be 8 times the 2.35. And for dogs, they're telling me 14 dogs. So I'm going to, instead of Y, I'll have 14 here. And let's see if this is true, if this is possible. So what I'm going to go ahead is I'm just going to put this on this part right here into GeoGebra. Or you can do the math and then add it up and see if it actually equals to 89.50, if that's possible. Now, if you see my screen right here, the total over here for 8 cats and 14 dogs will be $95.80. So that doesn't make sense because we're actually trying to get to $89.50. So this having 8 cats and 14 dogs will actually be more than what is saying here. So that is not true. So over here, I keep pressing that. So this part is not true. So it's not equal to, it will actually be equal to $95.80. And 80 cents. Now, remember the question, are Pat's numbers possible? Use your equation. So you could write, no, the numbers are not possible because the having 8 cats and 14 dogs will actually equal to $95.80 instead of the $89.50. So no, they are not possible, but you have to do the actual write-up. And notice how I use my equation. The last part says, later Pat found a record showing that there were a total of 22 cats and dogs at the shelter. So we have new information now, 22 cats and dogs at the shelter on Wednesday. How many cats were at the shelter on Wednesday? So, and that's our question. We're focusing on the cats. Now, notice how we already had the equation in the beginning telling us how much money they wasted. So this first equation, you already had it because that was telling you how much money was actually wasted on Wednesday. So I have that equation. I could write it here again. But we get a new piece of information that's 22 cats and dogs. So that means the cats, again, what are the cats represented by? In the beginning, we said that the cats will be represented by X. So cats, cats plus the dogs is represented by Y, are equal to 22 because there's 22 in total. Now, what ends up happening here is that now you have a system of equations. When I say system of equations, I mean you have two equations or more in some cases. So we have two equations. So we have the top equation, which represents the money wasted on Wednesday, and the bottom equation, which represents the total number of cats and dogs that were there at the shelter on Wednesday. Now it's asking me how many cats were at the shelter on Wednesday. What you can simply do is when you solve system of equations, you can solve them by simply going ahead and solving it graphically. So instead of solving algebraically, you can just solve it graphically. So x plus y equals 22. That was one of my equations. And my other equation was 2.35x plus 550y equals $89.50. Let me just double check. Yep. And now when you solve systems of equations and you graph them, you'll notice that if they have a solution, they will cross, they will intersect at a point. So they cross right here. You see how they intersect right there. So the intersection point is 10, 12. So right now I'm gonna go ahead and just type it up here. So 10, 12, that is my point of intersection. But remember that when we look at points, we know that the first number is your X and your second number is your Y. Now, the question was asking me how many cats. If you recall, cats were represented by which variable, the X or the Y? And if you did your annotations, you would see it right there that it's the X. So there were actually 10 cats on Wednesday. There were 10. And that's it. That's pretty much it. So you solve by finding the intersection, but you do have to be mindful of the variables. So if you said that the cats were X, you look at the X and the dogs are the Y. But in this case, they're not asking us about the dogs, but we just keep it there just in case. That's it.